In this video, we're going to go through and look at how to graph some ellipses. So if I can just remind us of what the equation form looks like for an ellipse. Right there we have the x times h over a and the y minus k over b, which is squared, and it equals 1. So for the first example, we already have the graph of our ellipse. So first thing we need to do is find the center. So if I go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 across. If I go 6, 1, 2, 3, 4, 5, 6, it puts my center right there. So I can label my center as 1, comma, -2, which right here gives me my h and k. So I have those two pieces already of my equation. My a and my b are not going to be that difficult. A is the distance from the center to the outside in the nth direction, so a is that distance right there, which is 6, and b is the distance out, which here is going to be the distance out 2. A is in the x direction, b is in the y direction. Then my major axis, in this case major, remember major means longest. My longest axis is 12 because it goes the whole way across, and minor means shortest. My minor axis is 4. I can go through and remember that the vertices are at the end of the major axis. So the vertices are going to be 7, comma, -2 and -5, comma, -2. Whereas my co-vertices are at the end of the minor axis. So that's going to be 1, comma, 0. And I'm going to have 1, comma, -4. 1, comma, let's go this way right now. Let's go away from that. Maybe I'll get better. 1, comma, -4. Better, not great. So it's a -4. So my vertices and co-vertices are points. And to write the equation of my list, take all the information I have up there, and it becomes x minus h, or opposite h, is minus 1 squared all over a squared, which would be 36, and then plus, and I have y minus k, or y opposite k, would be 2 squared, and this is all over 4 equals 1. So there's the equation of my ellipse, and all of the other vocabulary terms put into the right places. So the key here so far is just remembering what that vocabulary means. When we get down to example 2, notice how the ellipse is now oriented the other direction. That's not going to change anything except what I call my minor and my major axis. So if I find my center, it's going to be right there at 3, comma, -2. So there's h and k. A is still the direction, or still the distance in the x direction. So that's still A, 1, 2, 3. And B still goes in the y direction. So that's going to be 4. My major axis is now up and down. It's vertical. So it's going to be a total of 8 on the major, 4 from the top and 4 from the bottom. The minor axis is now left-right because it's the shorter one, and that's a total of 6. My vertices are here and here at the end of the major axis. So my vertices are 3, comma, 2 and 3, comma, -6. My co-vertices are at the end of the minor axis. So it's going to be 6, -2, and also 0, -2. So there's all that vocab. I can write my equation of my ellipse, just like I did before. X opposite h is -3 squared all over a squared, which is 9, plus y opposite h would be +2 squared all over b squared, which is 16, equals 1. That's all we did in the previous example. But now the difference is we have to find the foci. The foci are slightly more difficult. So I'll slow down a little bit for those. Remember that the c value is either the square root of a squared minus b squared or the square root of b squared minus a squared, whichever one is a positive value. So if a is bigger, it goes first. If b is bigger, it goes first. So my c value here is going to be the square root of b squared, 16, minus a squared, 9, or the square root of 7. Now, just in the back of our minds, we're going to go ahead and figure out the square root of 7, and we're going to realize that he's approximately 2.6. I'll say 2.6. It's about what it is. 2 and some change is what I know. So if we remember from the definitions that we gave first of all on how to find the foci are a distance of C away from the center on the major axis. So a distance of 2.65 along the major axis. So the major axis in this case is going to be the vertical one. So if I go a distance of 1, 2, and 0.65, 1, 2, and 0.65, those right there are my foci. I guess I can just call that singular if I want to call it a focus. So that's a focus, and the other one's a focus. Now remember what's so important about the foci is that those are the 2 points that determine how I actually create this ellipse. Now if I want to write out the foci, the way I always do it is I encourage people to go back and just write out the center, because the foci is just a deviation from the center. So my center was 3, -2. Now I look at which direction the foci are, and they're on the vertical, so that's changing the y value. So I'm going to come to this -2 and say, okay, I went plus and minus a distance of √7. So from the -2, from this -2 right here, I went a positive √7, and I also went -7. So I wrote my foci in this kind of shorthand form here. You could go ahead and kind of figure out what those are. You could write them out separately, but that does represent 2 ordered pairs with the plus and the minus. If the major axis had been in the x direction, I would have put the plus or minus with the first part, but since it's in the y direction, I put it with the second. So there's the location of my foci along with the equation of my ellipse. For our next example, we're going to actually just graph everything. We're not going to have the graph there to analyze. So if I start reading information, I have k for my equation. So my center is -2, I go to -2, -3, at the center of my ellipse. The a value is going to be the square root of 9, which is 3. The b value is the square root of 25, which is 5. So I move 3 in the x direction, 1, 2, 3. Both ways, 1, 2, 3. Move 5 in the y direction, 1, 2, 3, 4, 5. 1, 2, 5. And I can actually go ahead and graph my ellipse just based on those points. It's not the best graph ever, but it will do. To find the major axis, I look in this case, it's going to be vertical because it's longer going up and down than it is left and right. So my major axis is 10. And my minor axis is going to be left right because that's the shorter one, so that's 6. Now since the major axis goes up and down like this, right down through there, I know the foci are going to be along the major axis. So my first thing to do is go ahead and figure out what my c value is going to be. So in this case, c equals the square root of b squared, 25, minus a squared, minus 9. So in that case, I get c is the square root of 16. So my foci are going to be a distance of 4 away from my center, which is going to work nice. Now remember how I said before, I like to write this out as -2, negative. I go to the center, and then it's a deviation from there. In other words, I'm going plus or minus 4 in the y direction. So I added on to the y piece. In this case, it's kind of nice. 1, 2, 3, 4. We can actually put our foci in 1, 2, 4 and get the exact values of what it is. So -2, 1, and -2, -7. Most of the time, the foci are going to be some sort of square root distance away. In this case, it happened to work out nicely, but normally it's going to be an irrational distance. So we're not going to be able to write out the 2 ordered pairs separately without them both having square roots still. And last but not least, for the domain and the range, for the x values, they go from -5 all the way to 1, and the range just goes from negative up to. That's like we found domain and range all the time. So there's a fairly typical problem on graphing an ellipse. We're going to run through one more example, and I think one more on the next page, and then we will just have some time to practice these. So the last one, I'll run through at a pretty decent pace because everything's about the same on this one. I have 8k for my center. Here we go, 1, 1. The a value is the square root of that, which is 6. B value is the square root of that, which is 5. That is actually enough information to go ahead and graph my ellipse. Notice how I'm no longer in the x direction. 1, 2, 3, 4, 6. 1, 2, 5, 6. So my major axis is now going left, right. 1, 2, 3. Not by much, but it is. 1, 2, 3. So I'm going to try to sketch this to see how it goes. Not bad. So there's the graph of my ellipse. That doesn't take very long to actually graph one when we know what we're looking at. Major axis is the longer one, doubled, so that's 12, the whole way across from there to there. Minor axis is going to be the other one. I didn't ask for the vertices or co-vertices, but you can go ahead and identify those just by giving those ordered pairs that you graph. The foci this time are going to be along the major axis, like they always are. It's going to be left, right now. So I still find this t value the same. Square root of, this time it's going to be 36 minus 25. So c is the square root of 11. Check out what that is approximately. It's about 3.3. So that's approximately 3.3. That helps me to go ahead and graph these. I'm moving 3.3 away. So 1, 2, 3 and a little. 1, 2, 3 and a little. Remember what is important about the foci is those are the 2 points that help me construct this ellipse in the first place. That's why they're important. That's why we put them on. When I go to write out my ordered pair, the foci are a deviation from the center, but this time it's in the x direction. So I put the plus or minus root 11 with the x. And you could write that out as 2 separate ordered pairs, but that's essentially what is going on in terms of where those points are. So my domain, he's not bad to see, is -5 to 7, red apparently, and my range is going to be -4 all the way up to 6. So graphing an ellipse is not too bad. The most difficult thing is just figuring out where the foci are and being able to write out that ordered pair correctly as some sort of deviation in the x or y direction from the center of the ellipse.